Hello students, welcome to Solokem Lab. Today's chemistry class is on the topic test for lead-2 ions. Test for lead-2 ions. To test for lead-2 ions, we need a sample like this sample C here, which contains lead-2 ions. Look at this sample C here in solid form. It contains lead-2 ions. It's a solid crystal. We also need potassium tetraoxochromate 6, which has a yellow color that you were taught when you were in SS2 as you were studying redox reactions. Then we need a concentrated HCl. We need aqueous ammonia as well. And then we need a Bunsen burner, a device that we can use to heat the sample when we are expected to heat the sample. So to begin, this sample C that we have here, we are going to place it in an empty beaker. We put all of the C in an empty beaker. The next thing is to pour distilled water, about 20 cm cubed of distilled water. And then we stir. We stir the mixture. Why are we stirring the mixture? We are stirring the mixture to encourage dissolution. If dissolution is possible, we'll stir the mixture to encourage dissolution. After stirring, I'm going to observe, looking at the mixture here. Do you still see the samples of, you still see the sample C in solid form in here? No. That means sample C has dissolved, and it dissolved completely. So as usual, we need to report this. On that test, we write C plus distilled water. Under observation, we write C dissolves completely, and it gives us a colorless solution. What if we are asked to test with litmus paper? Here with me I have litmus paper, a red litmus paper. I'm going to test this sample with litmus paper. Do you observe any change on this red litmus paper? No change is observed. What about testing with blue litmus paper? This is my blue litmus paper. I'm going to test this resulting solution when I dissolve sample C in distilled water. Any observation? Blue litmus paper turns red. That means when I go to the inference, I'm going to say that the solution obtained from sample C is acidic. The solution obtained from sample C is acidic. Those are the preliminary things we need to do. Then the main work starts. The main work is to take about 2 cm cubed of this sample C, which we have dissolved in a test tube, about 2 cm cubed. And then to this 2 cm cube that I've collected, I'm going to add aqueous ammonia in drops first, then I add in excess. When I add in drops, what do you see? I'm seeing white powdery precipitate. White powdery precipitate. And so I'm going to report it. Sample C, as you can see on the board here, in aqueous form. When I add aqueous ammonia to it, what am I observing here? White precipitate. And the precipitate is in powder form. It's powdery, not gelatinous. White precipitate. That's when I added in drops. Then I have to continue and add in excess. Remember, when I add in excess, I'm looking out for, will this precipitate dissolve or will it remain insoluble when I add the reagent aqueous ammonia in excess? The observation I have here is that the white precipitate remains. It is insoluble. So I'm going to report it. Precipitate insoluble. For you to confirm that this precipitate is insoluble, you have to allow it to stand here in a test tube rack and you observe it after some time to confirm that the white precipitate is insoluble. We'll come back to it to observe it. Take note, this is the beaker, this is the test tube that contains the first reaction here. And so what are we going to infer at this point? We are going to infer that Pb2 plus or Al3 plus are present. Do you understand? Lead-2 ions or aluminum ions are present. Why do we report this or this? It is because either this or this will give us this same observation here, this same reaction, this same observation that we have in this test tube. So that is why we report that lead-2 ions or aluminum ions are present. Is that clear? Then we move on to the next test. The next test will be still to collect about 2 cm cubed of the sample C that we have dissolved in a beaker. Sorry please, in a test tube. Collect about 2 cm cube of this in a test tube, and then to it you are going to add potassium tetraoxochromate 6, which is yellow, which dissolves in solution, which dissolves in water here to give us a yellow solution. You add it. What do you observe? I'm observing a yellow precipitate. Yellow precipitate. So you report it as usual. Yellow precipitate. When you have this yellow precipitate, which ions do you suspect? You suspect lead-2 ions and also aluminum ions. Do you understand? While you allow that to stand, we'll go to the next test, the last test, which we'll call the confirmatory test. In the confirmatory test, we need to heat. And if we need to heat, that means we're not going to work with test tube again, because it can easily be broken by heat. It doesn't withstand heat. We need to work with a boiling tube. Did you notice that boiling tube is bigger than test tube? We work with boiling tube. So you collect about 2 cm cubed of the sample C in a boiling tube. Then you add 2 to 3 cm cube of concentrated HCl. And here we have our concentrated HCl. With the help of my dropper, I'm going to add 2 to 3 cm cube of the concentrated HCl. And when I add, what do I see here? White precipitate. White precipitate. The next thing I'm going to do is this. I'm going to heat this mixture to observe if the precipitate will dissolve or if it will remain insoluble. And to do that, I need my Bunsen burner. Right in front of us here is an improvised Bunsen burner. An improvised Bunsen burner. So I'll light it up. And for me to hold this boiling tube, I cannot hold it with my bare hand while I heat. I need to make use of my test tube holder, which is this, the wooden test tube holder. Then I'm going to heat. Take note of the volume of the precipitate we have here. It's about half of the volume of what we have in this solution. As we heat, the precipitate, will it dissolve or will it remain the same volume that we have here? Let's see. While you heat, make sure you face it away from other students and away from yourself, so that in case the solution spills, the mixture that you are heating spills, it won't cause any problem. And as you heat, you try to shake the content of the boiling tube gently. Remember what you want to find out. Will the white precipitate dissolve or will it remain? That's what we want to find out as we heat. when you observe, you'll notice that the volume of the precipitate we had before we started heating has reduced greatly, and we're having clear solution up. That means the precipitate is actually dissolving when heated, when warmed. So let's heat it a little more and observe. Let's observe. The volume of the precipitate has greatly gone down, meaning that the precipitate dissolves when warmed. Do you see the clear solution up there? Telling us that the white precipitate which we obtained when we added concentrated HCl has dissolved when warmed. The experiment does not end there. We will keep it to stand, allow it to stand, and then observe what happens when the warmed mixture cools. While we are waiting for that, let's go back to the board and see how to report this experiment. Sample C in aqueous form, when it reacts with HCl in concentrated form, concentrated HCl, you heat it, you observe that white precipitate forms when you add HCl. Then when you heat, that's when you warm the solution. The precipitate dissolves. Now we have allowed the precipitate to cool. We expect that this precipitate which dissolves when warmed will reappear on cooling. And if that happens, that confirms the presence of copper 2, of lead 2 ions, please. It confirms the presence of lead 2 ions. Did you notice that we're no longer mentioning aluminum ions? Because this is a confirmatory test. It's only lead 2 ions that will give us this reaction, this observation that we have here, when we add concentrated HCl and then heat. Do you understand? While we wait to see what happens as we allow this mixture to cool, let's check the first mixture we had. When we added aqueous ammonia, we obtained white precipitate, and then the precipitate is insoluble. And we said to confirm that it is insoluble, we have to allow the mixture to stand. Now that we've allowed it to stand, do you see these sediments at the bottom of the test tube? That shows that the precipitate is insoluble in excess aqueous ammonia. That's for the first experiment that we reported here. Do you understand? Do you have any question? Remember, we are still watching to see what happens to this test tube that we call the confirmatory test for lead 2 ions. As we allow it to cool, gradually the precipitates are building up again. And if actually the precipitates reappear on cooling, it means that copper 2 ion, that lead 2 ions are present in this sample C that we started with. Do you understand? That is how we test for the presence of lead 2 ions in the chemistry laboratory. Do you have any question? Don't fail to drop the question at the comment area, and we'll meet again in subsequent classes and we'll talk about the question you may have dropped. Thank you.